Here's a typical homework assignment that you'll have to do for the linear algebra module. You can see we've got the tasks up at the top here, and down below we've got this window containing the computer programming exercise. Now, what I recommend you do is you click this so-called burger button up at the top here. That'll make the screen a little bit bigger, allow you to see a little bit more of the programming. Okay, so it's not particularly convenient having the tasks up above and the programming down below. But what you might like to do, for instance, is to open this page in two tabs and have one to the side so that you can read the tasks, for instance. Anyway, we've made a start here on the programming. I've just typed in the definition of the first matrix, which is asked for in the first question here. And if you haven't used this replit environment before, I just want to point out the main features. There's basically three parts to each exercise. On the left-hand side is what's called the file tree, and this allows you basically to navigate through all the files. For most of the exercises you do for this module, you'll only really be working with this main.py file. You don't need to worry about the contents of this .replit file or the test main file. These are basically what check your exercise to see if it's done correctly. In the middle then is the text editor, and this is where you can go in and make changes to your code. So we can change the values here, for instance, and type commands in. And on the right hand side is where you will see the output of your code and any error messages and indeed any feedback on whether or not you've done the exercise correctly. So once you've sort of put in a piece of code, it's important to run it to check that it works correctly. And for all of these exercises, the first time you hit this run button, it will go through a series of installations. It needs to install certain packages to make sure it can do the symbolic Python. That's why it's installing SymPy here, but also to make sure that it can test your code to make sure that it's been done correctly. So for any given piece of code, there's two aspects to it. One is, has it been written correctly, i.e. without bugs? And two, does it do the correct thing? So here it's run through the installation, and it's attempted to run my code, and it's now given me an error message. It says attribute error. This module SymPy has no attribute matrix. Now, I know what that means because I do programming all the time, and I deliberately put this error in. But if you get an error message like this and you're not clear on what it means, I've put this helpful little button down at the bottom. You can go ahead and click on that, and it will take you to a list of error messages. The error we got was attribute error, and you can read the description for attribute error, and you can see what you've done wrong. In this case, I've actually even included this as a sentence at the end. A common example is using the matrix method in the SymPy library. It is easy to forget that matrix should be capitalized. So that's where we went wrong in the exercise here. I have typed in matrix with a little m. So I can go ahead and change that, and I run again. So now the code has executed correctly. I.e. there are no bugs in it, and I can see that because I'm getting these messages which are giving me feedback on whether or not the exercise is being completed correctly. Now the only variable which I've attempted to set is this Q1A. So I can scroll up to the feedback on Q1A, and it's telling me that we've got the wrong values. Okay, so this is what was expected, 1 minus 2 0, but instead what it got was 1 2 0. So basically I've left a minus sign out here. I can go ahead and put that minus sign in and run again. And when I do that, I should get yes. Okay, so now this variable Q1A is set correctly. So this package AutoFeedback is designed to give you feedback on what has gone wrong, if anything, in the code. So it's not if there are bugs. The bugs will be picked up in the first part where you get error messages and so on. But it's whether or not you've got the right number of elements in your matrix, for instance, or whether the values are correct or not. Okay, so once you've set each variable correctly, you'll get a green message saying that that variable is set correctly. If you make mistakes, you'll get a red message telling you what to try to fix it. Eventually, you will have solved all of the problems, so work through all of the tasks here at the top, stored all of the variables correctly here in the code, and you'll get a whole stack of green messages. It'll say Q1 is correct, Q1L is correct, and so on. Once that's done, then you can go ahead and hit submit, and that will be that exercise complete. Okay, that's done. If you get stuck at any point, so you're not getting anywhere with the exercise, perhaps you don't know the right commands to use and you can't find them in the instructions, there's always this button you can click on here, and this takes you to a page where you can ask for support with the Python course. So this will actually flag a little support ticket with myself and the extra demonstrators. All you have to do is fill in your name, your email address, and the name of the exercise you were working on. So you can find that. There's a little screenshot there of what you need to put in. And also I'm asking here for a short description of the problem and what you tried to fix it. Because this isn't designed to just be you give up. This is, you tried a few things, still not working, go ahead and hit submit, and somebody will get in touch with you about your code. Good luck.